Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll be learning the second subtopic of chapter 1 on quadratic functions and equations in one variable, okay? So, what is the relationship between a quadratic function and a many-to-one relation? So this is the topic that we'll be learning today. So let us recall, a quadratic expression is written in this form as what we have learned in the previous video, okay? Whereas this is a quadratic function, okay? So we can see that here is fx. Fx is a function, okay? So mind stimulation 3. Let's go through these 4 steps, okay? Based on the graphs of functions fx below, draw a line which is parallel to the x-axis on graphs B, C as in graph A, okay? So this is graph A, and we can see that they already draw a line using this ruler, okay? So we'll do the same for B and also C later, okay? Then step 2, mark the points of intersection between the graph of function fx and the straight line. Okay, so let's do this step 2 first, okay? So for B, fx equals to negative x squared plus 4x plus 1. Let's draw a line which is parallel to the x-axis. So I will draw the line here. Okay, you guys will be drawing this line using a ruler. Okay, so mark the points of intersection between the graph of function and the straight line. So this is the first intersection and this is the second intersection, okay? So there are 2 points of intersection. So step 3, state the number of points of intersection. Yeah, we already did it. And the coordinates of the points of intersection, okay? So this first point of intersection is 0, 1. Then this second point of intersection is 4, 1. Okay? Then let's repeat these steps for part C. So part C, fx equals to x squared minus 3x plus 2. So now I will draw the straight line here. Okay? And then we can see that this is the first point of intersection. This is the second point of intersection, okay? So there are 2 points of intersection, okay? And the first coordinate is 0, 2. The second coordinate is 3, 2, okay? So from this mind stimulation, it already shows that a quadratic function has a many-to-one relation, okay? Okay, let's say for C, okay? For x equals to 0, y is equal to 2. For x equals to 3, y is also equals to 2, okay? So let us recall what we have learned. So here is the object, here is the image, okay? So 0, 3. Then the image is 2, okay? Okay, so it is clear that it is a many-to-one relation, okay? So all quadratic functions have the same image for 2 different objects. We already shown it here, okay? So I hope you still remember. We have learned it before this. So the type of relation of a quadratic function is a many-to-one relation, okay? Then mind stimulation 4. So this mind stimulation 4, you guys will do it at home, okay? So the conclusion from mind stimulation 4, we'll find that for a graph of fx equals to ax squared plus bx plus c, if a is greater than 0, it is a smiley. If a is less than 0, it is an inverted smiley, okay? So this shape of a quadratic function is called a parabola, okay? So what is the maximum or minimum point of a quadratic function? So let's refer to this diagram 1, okay? We can see that it is an inverted smiley. So from here we know that a is less than 0. And we can see that this is the maximum point of this parabola, okay? So the highest value of y coordinate is y1, and x1 is the corresponding value for y1, okay? And the maximum point is having this coordinate, okay? x1, y1. And then in this diagram 2, it is a smiley, so we know that a is greater than 0. And we can see that this is the minimum point. So x2, y2 is the coordinate of the minimum point, okay? And y2 is the lowest value of y coordinate, okay? Then x2 is the corresponding value. So mind stimulation 5. This you guys will do it at home also by using the dynamic geometry software. And then from the graph shown in the software, you guys will be able to fill in all this information, okay? So what we will be learning in this mind stimulation 5 is, okay, this is the general form of a quadratic function, and for a less than 0, the graph has a maximum point. Because a less than 0, it is an inverted smiley, okay? This is the maximum point. And for the case of a greater than 0, it will be a smiley, okay? So it has a minimum point, okay? So what is the axis of symmetry of the graph of a quadratic function? The axis of symmetry is a straight line that is parallel to the y-axis and divides the graph into two parts of the same size and shape. Or we can say that the axis of symmetry is a straight line that is parallel to y-axis and it passes through the maximum or minimum point as shown here, okay? So mind stimulation 6. So in this mind stimulation 6, we'll be learning on how to identify the axis of symmetry, okay? So like in the first function, as what we have learned just now, the axis of symmetry passes through the minimum point, okay? And it divides the graph into two parts of the same shape and same size, okay? So in this case, this line is the axis of symmetry, x equals to 1, okay? So let us draw the axis of symmetry for B. fx equals to 2x squared plus 4x minus 3. So this is the shape of the graph. This straight line will be the axis of symmetry, okay? So you guys will be drawing it with a ruler. So it passed through the minimum point. And we know that this line is x equals to negative 1, okay? Then for C, fx equals to negative 2x squared plus 4x plus 2. And the graph is as shown here. So we know that the axis of symmetry is this straight line. It passed through the maximum point, okay? And we know this straight line is x equals to 1, okay? So again, let us recall the axis of symmetry is parallel to the y-axis and it passes through the maximum or minimum point, okay? So this self-practice 1.1b, you guys will try them at home, okay? If you guys have any questions on all these self-practices in the textbook, I have prepared an online course for you guys so that it can assist you guys to complete your homework at home, okay? So I'll see you in the next video. We'll be learning on the effects of changing the values of a, b, and c on graphs of quadratic function fx equals to ax squared plus bx plus c, okay? So do not forget to subscribe to my YouTube channel and I'll see you in the next video, okay? Bye bye.